Hi, so today I will be answering the second question for molecular biology in conservation. So this is the question. So we are required to get 9 DNA sequences of 9 different taxa, which can be different species, genus, or family. And we will need to search and download 9 DNA sequences that are most similar to the DNA sequence that have been processed previously. After we have downloaded the DNA sequences and obtained the organism information, the information must be arranged in a table from top to bottom by percentage similarity. So, to get 9 DNA sequences, we will use the NCBI BLAST. So first, what we need to do is open the DNA sequences, and in this case I choose the A03 file, which I already identified as Ceratitis forcera. And so just double click on this and then copy the DNA sequences and then open NCBI BLAST and go to nucleotide BLAST. And then paste the DNA sequences in this box. And then click the BLAST button. So I already choose 9 new DNA sequences from this list, and the list is this one. This is the sources. The first one is the API files that was given, and the other 9 is from GenBank, and this is the family. The first 9 organisms is from the same family, which is Cheriena, and the last is from Drosophilidae. The species, this is the species, and this is the percentage similarity, which have been arranged from the highest to the lowest percentage. After finish, so I already list it here in my WhatsApp. We just copy and then we open the GenBank. And then just paste it here and click search. And we will see this in our screen. So we just click on the summary and click FASTA text. And then we just copy everything, the DNA sequence, copy, and then open Notepad, just paste it in the Notepad. Make sure everything is already here, and then we just save it as whatever you want to save it as. I will save it as gene bank, and then save it in FASTA file, and then all files, and then just save it. So I already saved it as gene bank FASTA file, this one, and after that just go to bioedit sequence alignment editor, and then we open the FASTA file that we saved. The gene bank FASTA file, open. Then this is the sequences, but yeah, and then just click on the accessory application and click on the cluster with multiple alignment, run cluster W. Okay. Just wait until it's done. So this is the new alignment. Just the new alignment. And just save it. Save this as a new alignment and save it in a FASTA file. After that, I already saved it as FASTA file. You need to open the Mega software. We will use Mega software to run the neighbor joining analysis and maximum parsimony analysis. So I just click this phylogeny, construct test neighbor joining tree, and then it is open. And then we'll run the first one for neighbor joining. First pick none and OK. So this is the first tree for the neighbor joining, and after that construct for bootstrap. So this is the tree for bootstrap for neighbor joining tree. And after that, run the maximum parsimony tree. First, none, click OK. And then the second one for maximum parsimony bootstrap. So this is the maximum parsimony tree for bootstrap method. And then we open this for the neighbor joining. You're gonna pick one to reroute. So I will reroute the Drosophila bromeliae. Just click on the branch and click the root. So it became the outgroup. And also for the maximum parsimony, we pick the same organism and repeat. It will become the outgroup. So for this one, so this is the neighbor joining tree with support value, and this is the maximum parsimony tree with support value. And then this is the neighbor joining tree with support value from bootstrap support value from neighbor joining and maximum parsimony. So for this tree, the bootstrap support value from maximum parsimony tree were annotated in the neighbor joining tree. The tree shows two major clades. The first one consisting 5 species, which are the Ceratitis catrata, Ceratitis capitata, Ceratitis curvata, Ceratitis divaricata, and Ceratitis annone. And the second consisting 2 species, which are Ceratitis cochlearia and Ceratitis sylvestre. This one and this one. So the Ceratitis venusta, Ceratitis cristata, and Drosophila bromeliae are the distant relatives of the group. This one, this three. And the Drosophila bromeliae was chosen as the outgroup since it is from a different genus. Outgroup. So next, we will run the maximum likelihood phylogenetic analysis by using the IQ tree in Cypress. So we just open, and then I need to click on the data and upload data. I already upload my data, the DNA alignment fast file. So After that, we go to task, create new task. But since I already run the task, I will just clone this one. And then input set. Click to the data that we have uploaded. And then select the IQ3 on X SEDE, and then set the parameter the same as we did in our tutorial, and then just save parameter. After save parameter, click OK. And then save and run task. Okay. And then after the analysis is done, we'll get an email, and after we get the email, just go to the task and view output. And then download the stdout file and save it as text document. And then the output IQ3 also download as text document. And then the output country, download it and save it as NUIC files. After we finish downloading all the needed files, all the needed document, we open the fig tree. And then click on File, Open, and then click on the output country NUIC file. Click Open, and this will be the maximum likelihood tree, and we will have to reroute the same organism as what we wrote in neighbor joining and maximum parsimony. So the organism was this one. Just click on it and reroute. Then it will be the out group. and then we click on this branch and click on the tree and increase node order, and yeah, it will be arranged like this. So this is the maximum likelihood tree that from the Fig tree software, and then this is the maximum likelihood tree with maximum parsimony and neighbor joining support value. This is the first one is the maximum parsimony, and the second one the neighbor joining, and then this is the maximum likelihood support value. So the maximum likelihood tree is almost similar with the neighbor joining tree. However, in the maximum likelihood tree, the Drosophila bromeliae is the only distant related sister group since it was chosen as the outgroup. Ceratitis capitata and Ceratitis catrata is the most close related to each other with the highest ML, NJ, and MP support value of 100%. This one. And the Drosophila as the outgroup. So next we will run J model test analysis. So before that we will have to open the DNA alignment FASTA file in Mega software. So I already opened the data. Just click on this one. Click on data, export data. And then click on the format, choose Philip 3.0, untick this one, and then press OK. So this is the new Philip document, Philip file that I saved. So next we will need to go to Cypress and then go to data and then upload data. So I already uploaded the Philip file, and then go to task. I will create new task. I already create one task for J model test. So the parameter I just follow the same one like we did in our tutorial. So after the analysis have finished, view output, and then I will download the std out file, and then the in file Philip J model test hotmail. After that, I will open the J model test Philip to choose the J model test best fit model. So for me, for my best fit model is HKY plus G. So this is all the information. After that, we will need to run the Bayesian analysis. So we'll do the same thing, open the FASTA file for our DNA alignment, then click data, export data, and then pick the Nexus PAUP 3.0 neglect, and then untick one, and then it will be saved as Nexus file, and when we click it, we can open it in Notepad. So this is and our Nexus file. And we must make sure that the data type is DNA and all the unnecessary things will be deleted. And then next we will make our Bayesian block by referring to our base fit model. So in the Bayes block we will include this information to run the Bayesian analysis. So for the Bayesian block command, for my model, this is the Bayesian command, Bayesian block command. So after that, we will go to Cypress and then go to data and then upload our data alignment with Bayesian block that we have already saved before, this one. And then after that, we will go to the task and we will run Bayes analysis, and for the parameter, I just follow the same one as we did in the tutorial. And after the analysis is done, view output. View output. And then view the in file Nexus. And we will need to download the std out. But before that, view first to make sure that the Bayesian analysis, there is no error in our analysis. So the analysis is successful. And then download the file. After that, after you have downloaded the file, let's cd out and the in file Nexus. We will open the Bayesian tree by using the tree graph. So open the tree graph. and then click, will open the file that we downloaded. This one. And then just do the same thing like what we did in tutorial 9, and then add support value. Support value should be from the maximum likelihood. So after we finish with the Bayesian tree. This will be our Bayesian tree. So based on the Bayesian tree, the tree shows two major clades, the first one consisting 6 species and the second one consisting 2 species. So the first one consisting 6 species, this one, the second one consisting 2 species, and this is the Drosophila bromeliae and Ceratitis cristata are the distant related sister group, and the Drosophila bromeliae is the outgroup. So this is the Bayesian tree merged with bootstrap from maximum likelihood support value. This is the posterior probability, and the one on the below the branch is the bootstrap value. So the Bayesian tree that are merged with the ML bootstrap value shows two major clades, the first consisting 5 species, the second one consisting of 2 species. This one and this one. So the Ceratitis capitata and Ceratitis catrata is closely related to each other. It is closely related to each other with posterior probability and bootstrap value of 1 and 100 respectively. This one. So the Ceratitis cochera and Ceratitis silvestri are the distant related sister group. Ceratitis cochera and Ceratitis silvestri. So based on this table, the Drosophila bromeliae is the most distantly related with percentage of similarity of 89.60% by referring to this table. And then the Ceratitis capitata and Ceratitis catrata is the most closely related to each other since they have the same percentage of similarity, which are 87.06%. This one. And then the Ceratitis cochera and Ceratitis silvestri are the 2 species with the highest percentage of similarity, which are 100% and 93.30% respectively. However, in the Bayesian tree merged with ML bootstrap value, these two organisms are a distant related sister group. This one. So that's all for my question to answer. Thank you.